On November 14, 1957, the New England Journal of Medicine published an article announcing the discovery of a unique degenerative disease of the nervous system. Written up by D. Carleton Gajdusek and Vin Zegers, the paper reported 114 cases of an unusual disease prevalent among the Fore people of Papua New Guinea and which had a preference for women and children. In his book titled The Collector of Lost Souls, Warwick Anderson said the two intrepid researchers described the rapid development of incapacitating tremors, disorders of gait, slurred speech and incoordination, leading inexorably to incontinence, coriform movements, rigidity, inability to swallow, starvation, and death. In the early stages, many patients displayed a marked emotionalism with excessive hilarity, uproarious excessive laughter on slight provocation, and slow relaxation of emotional facial expressions. The disease was known locally by the name kuru. Hello, I'm Ibrahim Imam and welcome to this episode of the Neurology Lounge podcast. In this episode, we will be exploring the peculiar disease CJD, which comes under the group of disorders called Prion diseases. Kuru earned its place in the annals of neurology not just because of its exotic location, it was also the first human prion disorder to be fully characterized pathologically. Kuru was eventually linked to the practice of endocannibalism, defined as the ritual consumption of loved ones after death, a practice that perpetuated the social bonds in those who practiced it. But the journey to the understanding of kuru was long and tortuous. And the man who made it his life work to elucidate the pathophysiology of kuru was the driven neuroscientist Carleton Gajdusek. Since 1957, Gajdusek had led the efforts to understand this fatal brain disease. But despite his extensive epidemiological and pathological studies of the Fore, Gajdusek was stuck until chance played its hand. And this was in the form of William J. Hadlow, an American veterinary pathologist who was working then in an English agricultural field station. Hadlow had chanced upon a traveling exhibit of enlarged photographs of kuru brain tissue at the Wellcome Medical Museum in London. In his book titled Fatal Flaws, J. Ingram narrated that William Jellison, Hadlow's colleague visiting from the United States, had visited the exhibit organized by Carleton Gajdusek and told Hadlow, who in turn went to visit a few days later. Hadlow found the resemblances with the brains of sheep dying of a disease known as scrapie as uncanny. According to Anderson and Ingram, the post-mortem findings of the brains of the sheep showed characteristic vacuoles or tiny spaces within the cells, which sometimes give the tissue a spongy appearance. And there was also an explosive proliferation of star-shaped cells called astrocytes. Scrapie at the time was considered a transmissible spongiform encephalopathy caused by a mysterious slow virus. In July 1959, Hadlow wrote to Gajdusek to point out the similarities between the appearance of human brains with kuru with those of the brains of sheep dying of scrapie. He also sent him a copy of a letter he wrote to the journal, The Lancet, in which he suggested that experimental induction of kuru in laboratory primates may show that it is also a transmissible disease, just like scrapie. It, however, took Gajdusek several years to consider implementing the recommendation. Clinically, sheep suffering from scrapie also behaved similarly to people who had kuru. Anderson wrote that they tended to become excited, rubbing their fleece against trees and fences, trembling and staggering, and sometimes they showed a high steppage gait or hopped as rabbits do. He added that for no apparent reason, sheep in flocks here and there would suddenly become skittish and clumsy, sometimes prancing, sometimes walking with their front legs, but trying to gallop with their hind legs. Ingram wrote that the sheep had a bewildered look much of the time and appeared to be suffering from some sort of intolerable itch, rubbing against tree trunks or fences until they were virtually naked. Ingram also pointed out that different breeds of sheep were differentially susceptible to scrapie, ranging from 78% in Hardwick to 0% in Dorset Downs. After 3 years of reflecting on analogies to scrapie, Anderson said Gajdusek eventually inoculated the brain of a newborn rhesus monkey with homogenate of the brain of a kuru victim named Iru. Gajdusek subsequently inoculated 7 chimpanzees who, 2 years later, began to stagger and tremble. After the neuropathologist Elizabeth Beck examined the brains of the chimpanzees, she reported that the appearance was indistinguishable from the kuru brains she had seen. By 1967, Gajdusek had successfully transmitted kuru 3 times serially from chimp to chimp, thus proving its infectious character. Gajdusek was a man who was as enigmatic as the mystery of the disease he set out to unravel. J. Ingram described him as a near genius with a swashbuckling temperament who had enormous physical and mental energy, and he brought both to bear in the mystery of kuru. Anderson, however, noted that from the height of being awarded the 1976 Nobel Prize for his work, Gajdusek was eventually arrested and handcuffed outside his house just before the Easter of 1996. And in February 1997, he pleaded guilty to charges of sexually molesting one of his Micronesian sons, who was 16 at the time. This was just one of many children Gajdusek had adopted from Papua New Guinea and who lived with him in the United States. Kuru and scrapie turned out to be one of a legion of transmissible disorders called Prion diseases, named by Stanley Prusiner, the Nobel Prize-winning neurologist who worked out the nature and mode of transmission of scrapie. In his memoir titled Madness and Memory, Stanley Prusiner recalled that his first contact with prion diseases was during his neurology residency when he encountered a patient with Creutzfeldt Jakob disease. He wrote that the mysteries surrounding this illness launched my scientific studies for the next 4 decades. The dominant theory of the transmission of CJD at the time was viruses, and yet he said he was perplexed because his own patient exhibited no signs of an infectious disease. It was this skepticism about the prevailing dogma that made his attending physician, J. Richard Barringer, to refer him to the work of Tikva Alpa on scrapie. Scrapie, as we have seen, was the disease of sheep, but also of goats, and was thought at the time to also be caused by a slow virus. Alpa's work indeed went against the paradigm, as she had marshaled several arguments against the possibility that scrapie was caused by a viral infection. Prusiner described how he became obsessed with the riddle of scrapie and CJD, and he considered researching the subject further. He gave a vivid description of how he went about solving the scrapie problem, a task so arduous that he said he might never have started the work but for the fact that he was already blinded by his fascination with the scrapie agent, and but for the hubris of youth. But he found himself in an extremely stressful scientific race once he started, a stressful race which he said would soon all but take over my life. Along the way, he came up with the term prions in his now classic science paper published in 1982. Surprisingly, he gave the name even before he had isolated the scrapie agent, an act that his colleagues and competitors condemned. He said this act of presumed hubris evoked skeptical and frequently hostile reactions, and at one stage he said he became the embodiment of the word pariah. Prusiner eventually isolated the scrapie protein and later the gene. But his epic research journey did not end there, as he carried on trying to unravel the amyloid fibrils and plaques that are associated with prion diseases. And this opened a Pandora's box of misfolded proteins across the late onset human degenerative diseases. Beyond sheep and humans, prion diseases manifest in a host of other animals, the most infamous being mad cow disease or bovine spongiform encephalopathy. This is transmitted through infected meat and bone meal. According to Ingram, bovine spongiform encephalopathy or BSE infected between 1 to 3 million British cows, killing about 180,000 of them, and that is apart from the about 4 million that were preventatively slaughtered. Other animals affected by prion diseases include mink, deer, elk, moose, and caribou. Prions, it turns out, are proteins that are normally found in the body, and they perform crucial functions such as in the regulation of the circadian rhythm, olfaction, nerve transmission, apoptosis or cell death, and importantly, memory. The problem arises when they become misfolded, as it did in kuru, now a disease mainly of historical interest apart from some long-living patients who are still alive. But even before kuru became recognized as a disease, a different prion disease had been marauding as a conventional disorder, first reported in 1921 by the German neurologist Alfons Maria Jakob. According to J. Ingram, Jakob described a previously unrecognized neurological deterioration in 5 patients who he said robbed them of their mental life and memory, eventually leaving them unable to walk, talk, or speak. He said they died completely demented within a year. Jakob graciously named the disorder Creutzfeldt Jakob disease because fellow neurologist Hans Gerhard Creutzfeldt had reported on another patient with what he, Jakob, thought was the same disease he had described. But surprise, surprise, recent analysis of the microscopic slides proved that Creutzfeldt's and indeed 3 of Jakob's 5 patients didn't actually have CJD as we know it today. CJD is now the most important prion disease, and it is distinctive for having sporadic, familial, and iatrogenic or man-transmitted forms. Someone who suffered with CJD was Sandy Bosman's husband, Howie. Narrating his story in the memoir titled Howie V Creutzfeldt Jakob disease, she chronicled his 16-month illness, which started with periodic signs of forgetfulness and memory loss, for which he had a brain scan, and this was normal. However, she said one day there was a significant change when he uncharacteristically went to bed early, complaining of feeling tired. That night, he woke up and experienced a barrage of different hallucinations and was apparently confused. He was admitted to hospital where his hallucinations persisted despite treatment with Seroquel, and in hospital he became combative. He was seen by a neurologist who diagnosed Creutzfeldt Jakob disease straight away. Quite a feat. Admitted to a psychiatric hospital, he remained uncooperative, agitated, paranoid, and displaying bouts of aggression. But he also had calm periods of relative lucidity. The features of classical sporadic CJD are rapidly progressive dementia, cerebellar dysfunction, visual disturbances, akinetic mutism, and a host of movement disorders such as Parkinsonism, tremor, alien hand, hyperexplexia, myoclonus, ataxia, and chorea. The manifestations also include agrypnia excitata, autonomic and motor excitation during sleep, characterized by stupor and by stereotypic autonomic gestures which resemble normal daily activities. Other presentations of CJD include different types of seizures, vertigo, nystagmus, hearing loss, and obsessive-compulsive disorder. The investigations of sporadic CJD include an MRI brain, which may show lesions, especially in the parts of the brain called the caudate, the putamen, and the cortex. Spinal fluid analysis is typically positive for the 1433 protein and the tau protein, and the levels of the proteins called S100B and non-specific enolase may be increased. There's also a highly specific and sensitive spinal fluid test called real-time quaking induced, or RT-QuIC. The EEG may also show periodic sharp wave complexes. Apart from classic CJD, there are also other acquired forms, of which new variant CJD is the most important. NV-CJD presents in younger people and is dominated by psychiatric manifestations such as delusions, hallucinations, anxiety, depression, apathy, and social withdrawal. An illustrative case of new variant CJD was Andrew, whose story was related by his mother, journalist Christine Lord, in the memoir titled "Who Killed My Son?" Lord said that she first noticed that her son appeared removed, less talkative, and more introspective in 2004. This was also when he became more moody, snappy, tearful, and frightened. By 2005, he had started losing weight and developing headaches. His symptoms steadily progressed with the emergence of short-term memory problems, poor balance, and involuntary leg twitching. By March 2007, she wrote that Andrew disappeared in front of my eyes. Every day there was another task he couldn't do. Andrew was eventually admitted to hospital, and after investigations, including an MRI of the brain, an EEG, and spinal fluid analysis, he was diagnosed with new variant CJD. The MRI in this condition typically shows what is called the pulvinar sign in 70% of cases, and the spinal fluid is positive for the 1433 protein in about 50% of cases. Genetic testing, as in Andrew's case, shows an MM genotype, which is homozygous for methionine at codon 129, which increases susceptibility to new variant CJD. That's only for the neurologist. She said by the time he died, less than 6 months after his illness manifested, Andrew was blind, quadriplegic, and unable to eat, move, or recognize people. The cause of new variant CJD is the transmission of bovine spongiform encephalopathy or mad cow disease to humans through meat products. Lord investigated the cause in a bid to understand why her son got the disease despite stopping the consumption of meat products since he was 6 years old. And she discovered that until 1997, the rogue prions that caused new variant CJD were rife, and they laced a variety of foodstuff. These included school meals, canteen food at universities and colleges, ration packs for the military, meals on wheels for the elderly, meals for hospital patients, a multitude of pies, burgers, sausages, soups, packet, frozen, and tin foods had all been produced using bovine mechanically recovered meat, or MRM. She also found out that infected cows were typically fed with meat and bone meal animal feed, which she said was produced using the bones, the brains, and the spinal cords of slaughtered cattle. And significantly, she said, diseased and deformed creatures were also part of the mixture. Other CJD variants are the Oppenheimer-Brownell variant, which presents with isolated ataxia or unsteadiness, the cognitive variant, the affective or mood variant, and the Heidenhain or visual variant. There are also several familial forms of CJD, which, according to Ingram, first came to light when Libyan Jews who emigrated to Israel in the 1970s started showing a familial predisposition to CJD. Their risk was initially thought to be due to their habit of consuming sheep eyeballs. Familial CJD is caused by mutations in the human PRP gene, and the onset age is in the 30s to 40s. Two forms of Prion diseases present only as familial forms. The first is Gerstmann-Straussler-Scheinker or GSS syndrome, and this is caused by mutations in the variant prion protein gene on chromosome 20. And the other is fatal familial insomnia, or FFI. In his book titled Consciousness, Adam Ziman noted that FFI was first described in 1985 in 14 members of a large Italian family. In this family, he said insomnia was invariably the first symptom, and over months, normal sleep and its associated EEG patterns virtually disappeared. Ziman also said the family members exhibited episodes of stupor accompanied by dreamlike experiences and behavior which were appropriate to the content of the dreams. It is perhaps worth noting that fatal insomnia may manifest as a sporadic disease rather than familial, and this is known as sporadic fatal insomnia. Beyond these established human prion diseases, there is an emerging concept that many neurodegenerative diseases are also prion-like in pathology, and these include Alzheimer's disease, Parkinson's disease, motor neuron disease, and chronic traumatic encephalopathy, that is a dementia following repeated head injuries. These are all diseases characterized by misfolded proteins. According to Ingram, even normal aging is now being considered a prion-like process. To explore the human dimension of prion diseases, I will be speaking to Barbara Ludwig, author of No Time to Cry, a memoir of her husband's illness with CJD. If you found the podcast enlightening and helpful, demonstrate it by clicking on the like button, and why not subscribe to the YouTube, iTunes, or Spotify channels of the podcast. And to explore the light-hearted side of neurology, you might want to check out my book, Surfing the Brain. And I also have a neurology database called Neuro Checklist if you want to feel the harder edge of neurology. Thank you very much until the next time when I'll be in conversation with Barbara Ludwig. Do join me then.